Polymorphism. Polymorphism is a fundamental concept in object-oriented programming that allows objects of different classes to be treated as if they belong to the same class. Polymorphism can be achieved in several ways, including method overloading, method overriding, and dynamic binding. Method overloading refers to defining multiple methods with the same name but different parameters, while method overriding involves creating a new implementation of a method that already exists in a superclass. Dynamic binding, also known as late binding, refers to the process of determining the appropriate method implementation to be used at runtime. Polymorphism is a powerful feature of object-oriented programming that enables developers to write more flexible and reusable code. With polymorphism, code can be written to be more generic, making it easier to maintain and modify. Additionally, polymorphism helps to reduce code duplication and promotes code reuse. Because polymorphism allows objects to be treated as if they belong to the same class, it also facilitates code reuse by making it easier to create generic code that can be used across multiple objects. One of the key benefits of polymorphism is that it enables code to be written in a more natural and intuitive way. By allowing objects to be treated as if they belong to the same class, it makes it easier to write code that is more expressive and easier to read. Additionally, polymorphism helps to reduce the complexity of code, making it easier to understand and maintain. Polymorphism can be used in a wide range of applications, from simple programs to complex systems. It is particularly useful in situations where objects need to be treated in a similar way, regardless of their specific type. For example, a drawing application might use polymorphism to enable users to draw different shapes, such as circles and squares, using the same set of tools and commands. In conclusion, polymorphism is a fundamental concept in object-oriented programming that enables developers to write more flexible, reusable, and intuitive code. By allowing objects of different classes to be treated as if they belong to the same class, polymorphism helps to reduce code duplication, promote code reuse, and make code easier to maintain and modify. Polymorphism can be achieved in several ways, including method overloading, method overriding, and dynamic binding, and is a powerful tool for building robust and flexible software applications. Method overriding and overloading. Polymorphism is one of the key concepts in object-oriented programming, Oopm, which allows the same method or operator to behave in different ways depending on the object or data type it is applied to. It enables us to write more flexible and reusable code, as we can define generic behaviors that can be customized and adapted to specific needs. Polymorphism can be achieved in Oopm through two main mechanisms: method overriding and method overloading. Method overriding is the process of providing a new implementation of a method in a derived class that has the same name and signature as a method in the base class, but with a different behavior. This allows the derived class to override the behavior of the base class and provide its own implementation. The overridden method must have the same signature, return type, and access modifier as the original method in the base class. Here's an example code snippet to demonstrate method overriding. Class shape. Public void draw. System.out. Println, drawing a shape. Closing curly bracket. Closing curly bracket. Class circle extends shape. At override. Public void draw. System.out. Println, drawing a circle. Closing curly bracket. Closing curly bracket. Public class main. Public static void main, string, args. Shape S1 equals new shape. Shape S2 equals new circle. S1, draw, output, drawing a shape. S2, draw, output, drawing a circle. Closing curly bracket. Closing curly bracket. In this example, we have a base class shape and a derived class circle that inherits from shape. The circle class overrides the draw method of shape to provide its own implementation. When we create objects of both shape and circle and call the draw method on them, the appropriate implementation is invoked based on the actual type of the object. Method overloading is the process of defining multiple methods in the same class with the same name but different parameters. This allows the methods to perform similar tasks with different inputs and outputs, making the code more concise and readable. The overloaded methods must have different parameter lists, which can differ in the number, type, and order of the parameters. Here's an example code snippet to demonstrate method overloading. Class math. Public int add, int a, int b. Return a plus b. Closing curly bracket. Public double add, double a, double b. Return a plus b. Closing curly bracket. Public int add, int a, int b, int c. Return a plus b plus c. Closing curly bracket. Closing curly bracket. Public class main. Public static void main, string, args. Math m equals new math. System.out, println m.add 2, 3, output, 5. System.out, println m.add 2.5, 3.5, output, 6.0. System.out, println m.add 2, 3, 4, output, 9. Closing curly bracket. Closing curly bracket. In this example, we have a class math that defines three methods with the same name add but different parameter lists. The first two methods add two numbers of different types, int and double, while the third method adds three integers. When we call the add method on an object of math, the appropriate overloaded method is invoked based on the number and type of the arguments. Both method overriding and overloading are essential features of polymorphism in Oopm, as they enable us to write more flexible and maintainable code that can adapt to changing requirements and scenarios. Static and runtime polymorphism. Static and runtime polymorphism are two types of polymorphism used in object-oriented programming. Static polymorphism is also known as compile-time polymorphism and is resolved at compile time, while runtime polymorphism is also known as dynamic polymorphism and is resolved at runtime. Static polymorphism is achieved through function overloading and operator overloading, which allows multiple functions to have the same name but different parameters or behaviors. This allows for more flexibility and reusability in code. However, static polymorphism has some limitations, such as not being able to use the same function name for different classes. On the other hand, runtime polymorphism is achieved through virtual functions and dynamic binding, which allows for the selection of the appropriate function at runtime based on the type of object. This allows for greater flexibility and extensibility in code, as new derived classes can be added without changing the existing code. However, runtime polymorphism can also lead to performance issues, as it involves extra runtime overhead. In summary, both static and runtime polymorphism are important concepts in Oopm that provide different benefits and trade-offs. Choosing the appropriate type of polymorphism depends on the specific requirements and constraints of the problem at hand.